Okay, descriptive statistics and inferential statistics. This is basically the two main branches that you are going to later learn in statistics. Statistic is the whole things, right? But under statistic, you have descriptive statistics and inferential statistics. Okay, specifically in chapter 1, right, you are going to learn descriptive statistics. Okay, what is actually the difference between these two? Let's just try to read out what being highlighted in this book first. Statistic is the numerical summary of sample. This numerical summary describe characteristics of a sample. So and then we have descriptive statistic, right? Is used to describe the basic feature of data by providing summaries about the sample data in a form of suitable graphical or numerical analysis. So descriptive statistic here, right? The keyword for descriptive statistic is describe, right? And what being described, right? It is actually describe the data that you have. So if you don't have the data, right, you can't really describe using descriptive statistic. You can't really describe it. So for example, you have data for group A, then you can only apply descriptive statistic for group A. Right? You can't really talk about other groups. You cannot really use descriptive statistic for other groups. That is what it means by um, providing summaries about sample data. Okay, and let's look at the term summaries here. What it done, it is actually it summarized the data. Let's say you have thousands of data. By using descriptive statistic, you'll be able to find a good information, right? A summary of that, the whole data, doesn't matter whether it is thousand, millions, by using descriptive statistics, right? Just like the one that we looked before, right? In the first page just now, and this is kind of descriptive statistic where I believe that data of Malaysian is a lot. We have thousand, we have millions actually, but we can actually find out some useful information by using this graphical representation of data. Okay, the same as for this one, right? You have this is actually information on expenditure, right? For, I don't know, maybe household in Malaysia, and you have of course a lot of them, and they are actually 2 years of worth of data, and to find the total, right, you should be able to just sum it, but to look at it specifically based on this kind of segment, you might need to look at it one by one, which is tedious. So just by tabulate it like this kind of statistical process, and should be able to find a useful information or useful decision to be made, right? Like this one, right? This is all descriptive statistic. Okay, so that is the descriptive statistic, right? You have graphical and numerical analysis. So you can describe it graphically, and you can also describe it numerically, right? That is what we're going to learn at the end of this topic later. And we have inferential statistic. Inferential statistic, right, is inference, right, where we are going to make a decision about the population using samples. See, the key difference between descriptive and inferential statistics is that in descriptive, you don't talk about don't make a decision on a variable, right, or things that you don't have the data on it. So if you don't have the data, right, you don't able to really to talk about to analyze it by using descriptive statistic. However, inferential statistic is a different thing. It is one way ahead, where you don't have the data of that person, but you can still make a decision about it. Right? It is kind of making an estimation based on the sample data that you have. Okay, so that is descriptive and inferential. Okay, and parameter is the numerical summary of population. A numerical summary describes, okay, so any calculation or any statistical procedure made on population, right? Let's say you have the whole data of UNIMAP student as your population, and if you calculate the average CGPA of the whole UNIMAP student, that average, right, is a parameter. If you calculate a standard deviation, it is a parameter. Later we're going to see what is parameter, and later in sample we are going to use a different term. So for this one, any calculation made or any statistical analysis made on population data involve the whole population is known as parameter. Okay, right? What is the limitation of descriptive statistic? Try to think about it. I already told you the limitation of descriptive statistic compared to inferential. Okay, now this is graphically what is population and sample. Okay, I have already shown you before, right? What is population and sample? Okay, for population, whatever calculated is known as parameter, a statistically known as parameter. Okay, as for sample, whatever calculate using sample data is known as statistic. Right, so that is where the term statistic came from, because usually we don't have population data. It is hardly available, right? That's why you will conduct statistic. Okay, so this is the process, right? Actually, in inferential statistic, you are going to take a sample from this population using a sampling technique, and we are going to conduct an inferential statistic here, and later try to come up with a decision related to this population, even though you don't have the whole data of this population. For descriptive statistic, you can't do this. Right? If let's say you conduct a statistical analysis for descriptive statistic, you can only describe about the data of this sample alone. You can't talk about this population. I hope you clear with it. Okay. So this is what can be done between both descriptive and inferential, as in the definition of statistic before. Alright, using descriptive, we will be able to collect, organize, analyze, represent, and interpret that particular data. As for inferential, we can go further by making inference, estimation, hypothesis testing, and finding relationship and making prediction. This is all the thing that you're going to learn in this whole subject of EQT 271. All in this chart. Okay, so let's look at the parameter and statistic. As I said before, whatever being calculated using the data of the whole population is known as parameter, and anything being calculated by using the data, the sample data, is known as statistic. So as you can see, this is the kind of simple calculation can be made in statistic. In statistic here. So you can calculate for mean. When you have the data, you calculate for mean, variance, deviation, proportion, standard errors, among the things that can be calculated. And if you calculate it by using population data, right, you will get the same thing. I mean, of course, when you calculate for mean in population data, it will give you the mean for that data. Sample will also give you the mean, the average, but notice that the notation is different. So this is the notation for parameter. So mean for population data is denoted as mu, and mean for sample data is denoted as X bar. So why does this importance? Right, because later in statistics usually we don't really write down mean for population, no, mean for sample, no, usually we are going to use notation like this. So basically when it is written mu is equal to 50, so we know that 50 there is the average for population data. Right, if it is written down as bar, we know it is sample. Right, and again this is all known as parameter, and this is all known as statistic. Why? Because of the data that being used in calculating it. For population, parameter; for sample, statistic. Okay. Alright, so the next part will be collecting engineering data. We're going to discuss this in our next video. Thank you.